So how do I see the systems market shaping up? Essentially, it's this. There are two vendors, IBM and Oracle, that own their entire stack. They own their applications, the database, the underlying middleware, the infrastructure, the operating environments, all the way down to the processor level. They can tune these systems. They can create systems that are exponentially faster than their competitors. So I see a real slugfest there. And IBM's doing a lot of systems integration work. So is Oracle. Everybody else, by the way, becomes an x86 systems integrator, and they have to rely on a supply chain that they possibly control, but most likely do not. I mean, look at Hewlett-Packard with its Titanium systems. Didn't happen to own the Oracle middleware, nor the Oracle business apps, and suddenly that stuff was pulled off. Poor old Titanium just sitting there flopping on the deck. So that's another thing to talk about, too. The final competitors in this marketplace from a systems perspective will be IBM with System Z, IBM with its power systems, and then a bunch of x86 offerings from everybody. I believe that Titanium is dead in a doornail and will soon be canceled, and I just don't hold a lot of hope for Oracle's T4 and subsequent Spark-based systems. So what are the evolving product strategies for these companies? What I'm seeing from Oracle, for instance, is in their last announcement, their new T4 systems. I saw a couple of new integrated turnkey systems that were announced. One that did a human resources type application. And what they're doing is they're taking their applications, they're integrating them through the middleware, all the way through the operating environment, down to the hardware level and out. IBM does this to much, much better. IBM does it across 3 system types, Z, Power, and X. IBM's able to target certain workloads for certain processors and certain systems profiles, and the company's able to deliver some really exciting, super fast, exponentially faster computing environments than a lot of their competitors. Workload optimization is exactly what it sounds like. It's about optimizing workloads to run on computer systems. I separate it into 3 activities. The first is called tuned for the task. You know, no processor does every job perfectly. You know, some excel at serial processing, some excel at data processing, others excel at parallel processing. First thing you do when you're tuning for the task is figuring out which processor can handle the job best. The next thing you do is you look at the system design, because your users expect a certain quality of service. So you want a systems design that's highly reliable, highly available, then you find a systems design that has a bunch of redundant components. Or if you expect a system design that is very secure, you find the system design that has that kind of security level. So that's tuned for the task, and you're primarily looking at the processors and the systems designs. The second element of workload optimization is what I call pathing. What pathing is you've got an application and you want it to get down to the database, read the data, and have it processed really quickly. Well, think about the path it has to travel. It starts at the application layer, it travels through the infrastructure, down through the middleware layers, through the operating environment, to the processor layer, out to the database and back. And it does this a bunch of times to reach an end result. Pathing involves tuning those activities, finding the quickest path through and back such that your application performs extremely well, exponentially better than vendors who can't path. And incidentally, that's an important point too. There are only 2 vendors that I'm aware of that path well. IBM extremely well, and Oracle. And that's because both of these vendors have the ability to control the development and know where and how to tune across their entire stacks. The third activity in workload optimization is what I call, or what's called, application performance management. It's a set of tools, and it's tools that enable customers to take their applications, figuring out how those applications are behaving, and tune them to perform to their utmost potential. And that be largely used by customers who have custom applications that they're looking to workload optimize. So there's my really quick, short, succinct answer to what is workload optimization. Optimize systems in the cloud. Why would you do that? Well, as I look at cloud architecture, what I see is an environment that's consolidated, that's virtualized, that you can provision resources, and that you can have services delivered to you in a variety of different ways. Optimized systems role is to act as that consolidation point and that virtualization point. But what I want to see is I want to see people have the ability to easily provision those already consolidated, already virtualized resources and run their own jobs. You know, IBM's got an environment they call Blue Insight. And Blue Insight is I think it's back-ended by a number of mainframes and some other, maybe some power in x86. And what IBM has done is it's centralized the database, it's done authorization and authentication work, and it allows 200,000 employees to build their own machines within a cloud environment and access back-end data. Think of all the insights that IBM can get from that kind of activity. Think of all the new sales opportunities IBM might discover, or some of the competitive edges that IBM might develop. That's one element of the optimized systems within the cloud environment, and it's all about finding the resources quickly and being able to run your jobs. The second element, for those who want more advanced clouds, is the idea of usage and accounting. You know, if you've got a bunch of departments within your organization and they want to run a variety of jobs, some businesses want to be able to charge the department for its use of computer resources. Some of the most advanced usage and accounting and billing type of software that I've ever seen started in the mainframe with Usage and Accounting Manager and is now available for distributed cloud environments. So as I look at the role of optimized systems within these environments, I think you got to have systems that can be virtualized easily, provisioned easily, and in some cases where billing and metering can be done to enable the enterprise to recoup some of its investment. So as I look at business analytics and how optimized systems interact with business analytics applications, here's what I see. I see a lot of accounts where business analytics is siloed. It's sitting in the back room running on x86 servers or potentially a Unix server. And it's run by a department who may have their own database administrator, so they've created their own separate database, and that may have their own systems administrator. So it looks to me like an expensive, siloed, disconnected island of information used by precious few people, okay? You know, maybe it's a marketing department and 8 people have access, or a sales department and 3 people have access. You know, what you really want to get to, if you're going to make business analytics a strategic part of your organization, is you want to get to a scenario where you've got your data cleansed and centralized, and where you've got plenty of processing power available for people who want to run jobs. If they can run these jobs, they can gain new insights into what the business is doing. That will help your business run more efficiently. They can gain new insights into how products are being used in the market. That will help in the innovation cycle. They can gain new insights into what the competitors are doing. That will give you a competitive edge. You may find weaknesses used, you may find data streamed in over social media, unstructured data and structured data that you can use together to create competitive advantage. So how do these optimized systems play a role? Systems that are optimized are performing better than systems that aren't. And so what you want to look for is a vendor who can provide you integrated, optimized systems that can get you the results expeditiously and in a manner that is easily delivered to your end users. I see this all the time. IT buyers gravitating specifically toward x86 architecture because it's commodity and it's less expensive. And I see it all over the world, in some geographies more than others. But you're kind of missing the point if you always gravitate toward x86. x86 is a great architecture, especially the new multi-core technologies. But no single processor does every job well. Some processors do batch better than others, parallel, serial. Okay, so you should be looking at the workload characteristics. Now, as I'm looking at x86 architecture, that's a great parallel processing architecture, and it processes threads really fast. It's a great architecture for doing web-related type activities. But if I'm moving up the food chain, I'm going to be wanting a processor. Let's say I'm doing scientific computing. I'd want something like a Power. You know, or look at what Power did in its Watson implementation, something really advanced. If I'm doing a heavy I/O processing workload, I'm going to want to go with an IBM mainframe. Okay, huge I/O subsystem, hundreds of processors handling I/O, letting the main processor do all the computing work. So first, before you even gravitate toward x86, look first at your workloads. Now let's talk about the cost of the x86. As I look at x86s, I recently published a report where I took a heavy I/O workload on a mainframe and compared it to running the same workload on an x86 architecture. Now the fun part about this report is both machines ran 240 virtual machines. The mainframe had 240, the x86 architecture had 240. Ostensibly, the x86 system cost far less. It was like $300,000 for the 24 x86 servers that you needed to do this particular job. And for the mainframe, it was like $1 million or $1.2 million. But you know what? All those processors in the Intel world are rich in cores. And software is priced by the core. So when you got done adding all the software, all the virtualization software, all the application software, all the middleware, the total cost for the x86-based solution was $4.8 million. The cost for the mainframe solution was $3.3 million. The mainframe, performed the same job at a very high quality of service level in a highly virtualized environment for $1.5 million less than the x86 servers. So don't give me this, the cost acquisition on x86 servers is so low, how can I resist? You got to look at the workload or you'll end up paying a lot more money to process this same unit of work. So is enterprise Linux ready for prime time? I'm thinking back about 4 years or so ago when I used to go to Linux World in Boston. And you're walking around the demo floor, and what I saw was Linux as a file server, Linux as a mail server, Linux as a edge of network device kind of server. And I wrote about that. I said, Linux, it's not looking real snappy right now. It's looking like the old Windows 2000 back in the 1990s. It wasn't doing anything really fun and exciting. But on that same demo floor, you had the enterprise application people starting to show their products. And in subsequent years, there were more and more of these people showing enterprise applications running on Linux. Now let's fast forward to today and go to my website, World Wide Web, clabbyanalytics.com. I write a lot about customers who are using Linux in enterprise level application environments. One of my favorites, Colacem over in Gubbio, Italy, a medieval town nestled in the mountains about 2.5 hours northeast of Rome. These guys had a brilliant strategy. They deployed Linux on a mainframe, and what they do is they run their SAP, their business apps, and their business processes on the mainframe. They go out and acquire other companies in the same industry, dump their databases onto the mainframe, get rid of the processes, and do it all their way. It's an extremely efficient way to grow. Go find people that have customers, acquire them, assimilate them, and move on to the next one. Impressive story. The other one I really liked is in, of all places, Fort Smith, Arkansas, Baldor Electric. Baldor Electric went in, installed a Linux-based mainframe also, is running their enterprise applications in that environment, and they were slowly but surely taking out all their Unix Sun servers, rightfully so, and also taking out some of their x86 servers. What they were doing was consolidating those workloads, the appropriate workloads, on the mainframe. The mainframe's an impressive Linux consolidation engine, and it most certainly is ready to run prime-time applications today. It can rival Unix in terms of reliability, availability. There are some improvements that maybe need to be made in management, and certainly in the virtual machine environments as compared with Unix and the mainframe. But it's grown up. And by the way, Unix in the, Linux in the mainframe can take advantage of all the mainframe's quality of service benefits like security, like high availability, like reliability. Most definitely ready to play in the prime time. When Linux gets put on the mainframe, one of the things I like best about the mainframe environment is that it returns resources to the virtual resource pool a lot more quickly than x86 environments. So you're able to get really, really high utilization rates on your mainframe. You know, if you think about that, let's say you're running x86 servers, and I rarely see an x86 server running at greater than 40% of its total capacity. So you need more and more x86 servers to do the job. Okay, now let's take a look at a mainframe. A mainframe can run at 100% capacity for sustained periods of time. Now let's also take a closer look at the mainframe. A mainframe mean time between failure is measured in decades, not in months, days, years, hours, or you know, shorter time frames. You know, mainframes are highly reliable, highly available, highly secure. They can run these Linux workloads a lot more efficiently than trying to spread them out across x86 servers, where a lot of those workloads are going. Final one, and this one a lot of people seem to forget about, actually final two. A mainframe size-wise is about the size of a typical closet, okay? A x86 server farm really starts to burn up some data center space. But even more interesting, oil is right now about $100 a gallon, and you know someday it's going to go up closer to $200 a gallon. You know, you take an x86 server farm, you put the same workload on it that you put on the mainframe. The mainframe's going to burn about 12, 15, 20% of the energy of that x86 server farm in terms of not only power utilization, but also cooling. Okay? The mainframe has a ton of benefits if you're going to use it as a consolidation server. Final comment, IBM has greatly reduced the cost of the mainframe when it acts as a consolidation server. Check out IBM's solution editions for mainframes. Check out its Linux Enterprise server, and I think you'll be pleasantly surprised at how close the cost would be to the x86 alternatives. Last thing, remember that per core pricing. Software, go in the x86 route. Per core can get very expensive. Take a close look at the bottom line of what it costs you on a mainframe. And again, I think you'll be very pleasantly surprised.